All right, welcome everybody. So today's lesson is going to be on correlation and causation. This is lesson 4.5, and please make sure you have your books open to page 254. Today's lesson is kind of vocabulary heavy in terms of an understanding what the difference between a correlation is versus a causation. First things first, though, is the bell work. So please pause the video and work on this. All right, so one thing about this, guys, is that this first table here, does it have a positive or negative correlation? Well, if I were to take and draw out just a regular graph that sets up like this, and I used height as an independent variable because you can't control your height, okay, but you can control your weight. So if I were to just say 5 over 110 up, you would kind of see a little correlation that would go up like this. So is it positive or negative? It is positive, okay? The taller you are, generally speaking, the more you should and do weigh. And then what happens is this table here says about 5'6". What would you expect? Well, I'm looking at these tables here, and I notice between what you could technically do is do the slope formula, figure everything out. But for me, I'm going to use a little bit of common sense. Between here and here is 13. And between here and here is 14, okay? And this difference in space is about 2 inches, okay? So if I were to take this number, I'll take 13 and subtract it from 165, you should get the answer. So I'm looking at approximately, if I'm 5'6", I should be about 152 pounds is what basically you're saying. And then it says refer to the scatter plot on Jessica's visit. Use the points and write a slope-intercept form of an equation for that line. Okay, slope-intercept form, remember, is the y equals mx plus b. So you would find out your slope first. In this case, remember, it would be y2 minus y1 over x2 minus x1. Then you would just go ahead and plug in your equations. So I'm going to do, which one should I do? Doesn't really matter. So I'll go 4 over 100 minus, and then this is going to be 20 over 9. Is that right? Nope, I did that backwards. Early in the morning for me. It's fall break. Okay, so if you set this up, you'd have negative 5 over 80, which could probably be reduced down to... that would be 1 over, and then that would be 5, 13. No, wait, it's not right. 16. All right, so there's your slope. So if I want to put it in negative slope form, it would just be y equals my slope of 116. And then you pick a point, so it would be x minus, and I'll pick the 100 and the 4 because it's probably easier to deal with the 100, or actually I'll do the 20 and the 9 because that's smaller. And then so your x value here is 20, and it's going to be plus 9. And then since this is negative, remember, it's going to be y equals negative 1 over 16x. And then that would be a negative, and a negative is positive, so it's going to be plus 20 over 16 plus 9. Okay, and then you would just put everything together. 20 over 16 would be 1, and so let's just simplify this here. This can be simplified to 5 over 4. Then if I add that in, it would be plus, oh, don't forget the negative, 10 and 1/4. Now, the reason I got 10 and 1/4 is I changed this to 5 over 4, which is basically 1 and 1/4, so 1 plus 9 is 10, and then 5, and then you're left with 1/4. So there's your equation. Okay, so there's how you would do that, and that would create a good line of fit. If I were to test it out and look, my interceptions up here, and if I have a 1 over 16, it looks like it would be a nice little line that would come down like that. So looks like I have a pretty good line of fit. So now what you guys want to do today, what we're going to be doing is just talking mainly about distinguishing between what correlation and causation is. Okay, we did scatter plots last lesson. Now we're going to focus on these two vocabulary words. And it's very important that you guys understand the difference. Okay, correlation does not prove causation. And as a matter of fact, I put a definition here at the bottom. Okay, correlation is a relationship between two variables, and that's it. It just so happens to be there is a relationship between two variables. Okay, but if the two variables show causation, then a change in one directly changes the other. Okay, so what you would do is graph the points, determine if it's positive or negative, and then you would have to tell me whether the data shows causation, which means does one variable cause a change in the other. Okay, that's the big key thing we're looking for. So let's get started. Shauna measured the height of a sunflower plant after seeding. So what we have to do is find out which one of these is the independent and which one is the dependent variable. Well, the independent variable is usually time. So in this case, it's going to be days. Okay, so our days is going to be our x, and then our height is going to be y. Okay, even though I know we can't control the height, what we can't really control is the days. So once you plant it, that's how you'd measure it growth. Okay, is that when it grows up, then you can kind of see the vertical, how it would work vertically speaking. What I'm going to show you guys is kind of the beginning of a lesson for today that's going to carry on to lesson 4.6. Okay, so what I want you guys to do is open Desmos. I have it already open. I have it set on the side, and what you want to do is add a new item and add in table. And then what this allows you to do is allows you guys to rapidly enter data points. Okay, so what I'm going to do is when I usually enter data points, I go down vertically speaking first. So if my x values are 0, and then 10, 20, 30, 40, 50, 60, and then I go back up to the top, my y values are going to be 0, 0, 3, 11, 19, 26, and 32. Okay, simple as that. Plot them out. Let me go home here. And then let me make this graph bigger. And there's my little dots that you guys can see. Okay, so what type of correlation is this? This is of course, it's positive speaking, right? Okay, so is it a positive or negative correlation? It's positive. Now you need to determine whether the data shows causation. Okay, so the longer the plant is in the ground, will it grow? The answer is yes. Yes, it will. Okay, so does this have causation? The answer is yes, because the plant grows taller over time. All right, hopefully you guys understand. The longer the plant is grown, just like a tree, if you plant a tree in the ground, it's really small. But the longer it stays in the ground, what happens? The taller it gets. So the longer the time goes, is there a causation between the two variables? Yes, there is. That's what causation means. Okay. Now, what I want you guys to use is please use the same technique I just did. You go into Desmos and you create another table. All right. So you click and add another table right here. And then what I want you guys to do is enter in the coordinates points here. Remember, which one of these is independent? Okay, it's your hours worked. Okay, your hours worked would be your X, pay earned would be your Y. Enter these in, and then tell me if the scatter plot is positive or negative, and then determine the causation. So I'm going to work on the side, but I want you guys to continue to work, and you can see what I'm doing while you guys are working at the same time. Go ahead and get started. All right, if you have not finished yet, please pause the video, okay, for everybody that has finished, because I know I can type really fast. That's what happens when you do accounting work. You learn how to use the 9-digit keypad over here on my keyboard really quickly. If you have not finished, pause the video. If you have, then continue on with me. So what kind of correlation is this showing here? Okay, this is showing once you plot them, now are all these points in order? Not necessarily, okay, because I didn't really care about the month. Okay, I cared about your hours worked versus your pay earned. I didn't care about your month. So is there a positive or a negative correlation? Well, usually when it comes to pay, there is a what? Positive correlation. Okay. Now, is it a direct, is it a direct causation? Okay. What I mean by that, is there causation? Does one variable cause the other to change? Well, the answer to this would be what? It would be yes. Okay. Yes, there is causation. The reason the causation is the more hours you work, what happens? The more you get paid. Okay, pretty simple, right? It causes one. The more you work, the more you get paid. One causes the other. Okay, so hopefully you guys understand that aspect. We really didn't care about the month. Now, the month may have been erratic, but we're not looking for the month. We are looking for every hour you worked, did you get paid more? And the answer to that is what? According to what we plotted out, the answer is yes. Okay. Please make sure you guys understand that and that you don't get confused about that. Sorry, I keep going back to that slide. All right. Example 2. Tara shopping for a used car. Okay. She noticed a positive correlation between the age of the car and the mileage. Determine whether this situation is correlation but not causation, or is it causation? So on the standardized test, you guys are going to be given a situation like this, and you have to determine whether or not the two variables are linked. So she notices a positive correlation. So what she means by that is usually that would be the age of the car is probably down here, because you can't help that. Age of car. Okay. So what she's noticing is the car gets older. Okay. This is a new car over here, and the age would be going this way, right? So if you have a car that's 15 years old, what she's noticing is that the mileage of the car, okay, is, and so you have to draw a picture kind of, sorry I spelled that wrong. She's noticing that if I were to graph the points, that the older the car is, the more miles there is. Okay, so that's a positive correlation. Now, is it a causation? And the answer to this would be yes. Okay, the reason there is because the longer the car is driven, the more miles a car will have. I have a 1993 Nissan pickup that's sitting in my driveway right behind me that has, oh, can you see it from here? Oh, no, you can't. It has 267,000 miles on it, okay? And that's because it's a 1993. I have a 2010 van and a Scion, and both of those have less. They have like 130, okay? So, and then we have a newer car. It's my wife's that has like 33. So is there a difference in correlation? Yes. Now, will you find a used car sometimes that has low mileage? Sure, that happens. But most likely, the older the car is, the more miles it has. Okay. Last example, you guys need to look at these and tell me, do these two statements illustrate correlation but not causation, or is it causation? All right, hopefully you guys have finished this and you can understand what this means, okay? When mixing orange juice from concentrate, there is a negative correlation between the amount of water and the concentration of orange juice. If you guys have ever bought frozen orange juice, it tells you to add certain water. So you would start up here with, this would be water, okay? And then this would be orange juice. Okay, I just put OJ. That's a weird OJ, but it works. So your OJ concentration would be here, but the more water you add, what happens? Okay, the more water you add, the less OJ you have. So there's a negative correlation. So is this a correlation or is it a causation? Well, in this case, it is a causation, because the more water you physically add, it causes the graph to do what? To go down. How do you spell causation? Okay, ooh, that was horrible. Hold on. I'm like, I lost where the definition was. All right, and then lastly, Teresa sells crafts at a local flea market. She noticed a positive correlation between the number of necklaces and the number of toy puppets sold each day. So this would be puppets and necklaces. She happens to see that there's a positive correlation. Okay, so she's probably graphing it like this and is going up. Now, in this example, does one thing cause the other? This would be a no. This is a correlation, okay? But there is no causation, which means most likely what's happening is that when she's selling, she's having good days and she's having bad days. When she has good days, she sells a lot of necklaces and a lot of puppets all at the same day. But if nobody comes to the flea market, then guess what? Nobody buys anything, so the necklaces and the puppets will probably be down here on the low end. Hopefully you guys understand that there's a correlation, but there's not causation. That does not matter about the selling of necklaces, okay? She's not selling necklaces, and that's if she sells a whole bunch of necklaces, that doesn't mean she's also selling a whole bunch of puppets. It just happens to be that she's having good and bad sales days, okay? So that's the end of this lesson. On your guys' homework, you're going to be you have to identify the causations and the correlation. Remember, what it's trying to get you guys to understand is that if you physically change one thing, then it'll change the other. Just like our example, if you adding water, the longer it was in the ground, the plant, it directly caused or influenced something else. If it just happens to be like Teresa's example here, that you're selling necklaces and crafts, that doesn't really matter. If you guys look in your book, okay, you guys will see real world example 1 that's on page 254. It talks about the number of dogs and the number of cats that get adopted every month. And it has a positive correlation in the graph, but do they cause each other? No, they don't. They just happen to be a correlation, but it doesn't matter that there's a lot of dogs and cats adopted on the same day. That just means, guess what? Some days more dogs and cats get adopted, or some months than others. Okay, so there's really no correlation, or there's no causation, but there's a correlation between the data points. Okay, remember, go back to our original definition of what they are. Correlation is a relationship between two variables. On that example in the book, is there a relationship between the two variables? Sure, there is a relationship, but one is not causing the other to increase. Okay. Hopefully you guys understand the difference between the two, and if you don't, please come see me in class before we move on to the next lesson, okay? In the meantime, guys, it's been great, but I hope to see you in class soon if you missed today's lesson. If you have any questions, come ask me, work on your homework, and until next time, I'll see you guys later.